Good afternoon. Let's move on and I think it's the 5th lecture now. This is actually the final lecture that has something to do with actual doing, architecting. The rest of the lectures will focus more on special kinds of architectures or special usages of usage of architectures. So the title of today's talk, Quality Attributes or Architecting Quality, it's what we'll do today is that we will wrap up the idea of architectural reasoning. We looked into architecture patterns, we looked into tactics. Now we will look more at the reasoning, and more specifically we will also focus on the evaluation of architecture. What we'll do is that I will walk you through something called ATAM, which is the architecture trade-off analysis method. So it is a design/evaluation framework that I hope will show you the complexity of this this effort, or the architecture effort in a larger project. There are many stakeholders involved, there are many concerns involved, and they are competing, the stakeholders and their concerns. And the trade-off here really emphasizes the fact that we need to trade properties, one property for another, in order to reach this win-win situation. So what we're talking about is this framework with requirements on one end, architectural knowledge, the strategy that we form for our views using tactics and patterns. And then we have the quality attribute model, which is some kind of expression of the properties that we would like our architecture to exhibit with respect to the concerns, and we use that for our evaluation. And then we have the responsibility structure, and in the first level decomposition, what you did was that you allocated responsibilities to the components, and this is something that you will see that this is actually the way many of the operationalized, or I should say all the operationalized quality attributes, how they will be managed. We allocate responsibilities. And then, of course, we also have the patterns that we can use to somewhat enable different type or different qualities. So the focus here is really like quality. Provide for, enable quality. Make it possible for the developers to do their job. And if they do their job, the system integrity will give us the qualities we're looking at the system level. That is like the contract that you will get from this architecture effort. If we look at one important part here, the evaluation, we can think about when can we say something about the system's quality or a system's quality. If you look at modifiability, we talked about that at the end of last lecture. It was really related to good design choices. So abstraction, encapsulation, information hiding, modularity, etc. There are some well-known design principles. There are a lot of design patterns enabling these. And what you see is that some properties, the ones on the left-hand side here, they can actually be determined on the artifacts that describe the systems. So we can reason about modifiability. We can reason about reusability and to some extent also testability by studying artifacts, not the system itself. So we can study source code documents to determine the testability of the system, for instance. Statically discernible means that we can study the system without running the system. And this means, of course, that, well, we can, by reasoning about the architectural level, say something about these. On the right-hand side here, we have dynamically discernible attributes. That means that those are properties that the system exhibits when it executes. And these are also somewhat more challenging for us as architects because we will not have a running system. We will not have an executable system in the beginning of our projects. Further down the line, a couple of iterations, sure, but not from the very beginning. Still, we need to make decisions about performance, security, functionality, usability, etc. And there are two ways of doing this. Either, or I should say both of them are based on argumentation. The simple, straightforward argumentation is that you study your architecture and you come up with arguments why this architecture will support the functionality that is desired for this application. This is to some extent what I ask you to do in the first assignment. Allocate responsibilities for the functionality and argue a bit that this is sufficient. But when it comes to performance, it's slightly more complicated because, well, you can argue, but your arguments are not very strong. But what we can do, this will not be part of this course, but for instance, we can create a performance model. We can model the performance of the individual subsystems in the system. We can have performance models for the communication between the subsystems, and we can use that model to come up with projections, estimate for the performance. What will be the typical average latency? What are the worst case latencies we see in the system? What is the throughput of this component? And based on that, we can actually produce a performance model that satisfy the performance requirements we have on the system. And what's even better, since we model the parts of the system using this performance model, we have individual performance requirements on each subsystem. Do you see my point here? You create a model. You create a model for the entire system like this. And then you model latencies, throughput, etc. And you do that by tweaking numbers in the individual subsystems and the communication connections. And you do that until you have something that satisfies the high-level throughput requirements, the high-level latency requirements, the system-level requirements. When you have done that, you have the parameters for each subsystem, and they will then be the requirement on that subsystem with respect to performance. If you think about security, well, at the system level, you will allocate responsibilities to the subsystems. by allocating responsibilities, well, you will add requirements to these subsystems. So as long as the subsystems satisfy these new security requirements at the system level, we will have a security mechanism that satisfies the system level security requirements. So you have to approach these somewhat differently, depending upon if they are statically discernible or if they are dynamically discernible. If you look at the business qualities, they are even more or even fuzzier, I would say, and we just put them up there. We don't think about them too much. So here are the challenges, and I talked about them. They are cross-cutting, they are competing, and they are continuous. Continuous, by that I mean that functionality is either in or not. It's either there or it's not. But it doesn't matter how slow the system is or how fast the system is, it has a performance. Performance is there, but it can be good or it can be bad. If good means high throughput, low latency, and the opposite is bad. But the challenge here is, as I said, trade. To balance out the fact that the cross-cutting nature, that they are competing for the same resources, well, that means that we can, almost like sliders, up and down, tune the quality attribute levels in a way that we can satisfy all quality attributes. Good enough. That's the target. Okay. So how can we specify quality? We mentioned one way last week, but the quality model here is the starting point always. That quality is always specific for an application and its current context. They have to be very specific because if a requirement is not testable, it's useless. So if we say that the system should be fast, how do you test that? What is fast? Well, you have to specify it in more detail. So the quality model, and we had a look at this guy a couple of lectures back. This is like a template that can help you. It can be a guide when you check different attributes and you model your requirements. However, besides the attribute here and the level, you have to think about how do you measure quality? How do you, in your evaluations, or if it's your validation, the testing phase, how do you measure usability, for instance? How do you determine if some approach is more usable than some other approach? And I would say, and I would claim, and I will show you later in one of the later lectures, that actually architecture can be a vehicle if it is difficult to determine the quality. One example here is A and B or 50-50 testing. A and B testing is used by many large companies these days. What they are doing is that they don't really know which, let's say, UI or business process that produce the best value for them. Value in terms of sales or value in terms of satisfied customers, they don't know. It's very difficult to measure, and it's very difficult to project if this way of checkout at Amazon generates more revenue than another checkout procedure. So how do they do that? Well, they deploy two alternative processes and they measure. They measure the outcome of A and the outcome of B. And they do that for thousands of users. And suddenly they have a statistical foundation for a decision. That for us, A is much more productive. It generates more revenue than B. But if you want that mechanism in your system, well, that's an architectural decision. Because in fact, you have to make up a decision which parts should be possible to A and B test. This is for future development typically. So during maintenance, we would like to introduce a new feature, or we would like to introduce a new version of this feature. Should we do that or not? Well, that decision is difficult to make, but now you run it in A and B testing for some time, and then you have a material that you can base your decision on. But still, that requires architecture. An architecture that supports this. So we talk more about that in a couple of lectures. An alternative here was the scenarios. We talked about the scenarios, and here are some general scenarios for quality attributes, and in this case it's availability, but here, instead of trying to pinpoint levels of each and every attribute, what they do with this approach is that we specify scenarios. And this is a similar variation as you will see for functional requirements. You remember that there is you can express your requirements on a system like, well, using sentences. The system shall do this. The system shall do that. It's kind of challenging to do that if you want to be certain that you cover all the shalls that the system should do. Instead, we have started to use stories. Some people call them user stories, and there are something called use cases based on scenarios. That is more like a descriptive. Write the story, the system should behave like this. And this is the same variance as, but for quality attributes. Instead of saying that the system shall respond within 0.2 seconds, the system shall, well, you express it as a scenario. Under normal conditions, when this request arrives, it should, yeah, something like that. So what is important here is that we get a good start, that we get the requirements correct, as always. This is true for this, and this is true for everything you do. If you don't get it right, if you don't understand what, or if you don't get a task description correct, your requirements, it's challenging, to say the least, to meet the expectations. So what we're talking about is, in fact, how to go from requirements to design. So architecture is a first step where you take the overarching requirements and you come up with a system-level design that takes these requirements into account. How do you do that then? Well, you have seen a sketchy description of this in the previous slide decks, but you start with some general requirements, that is more or less which architecture concerns are important here. And for each of them, you come up with, in this case, the scenarios. You specify the scenarios for each and every concern. And you do that, who do you do that with? Who do you specify the scenarios with? Who has knowledge about the scenarios? Remember the ISO standard? Who has the knowledge about the quality attributes? Who is concerned with this? Well, it's the stakeholders. So together with the stakeholders, you elicit the scenarios, the concrete scenarios here. And then there is a process in the middle, but at the end of the day, we should arrive at some kind of responsibility structure, where we have allocated responsibilities, where we have structured this responsibility structure using patterns in a way that, well, we support the scenarios as described here by the stakeholders and organized by us as architects. But a middle ground here, we haven't spoke too much about it. It's more or less like a black box full of magic now, where you have your concerns, that's the requirements, and then you have, well, some kind of decomposition structure with responsibilities and interfaces down at the other end. But how do you do this? Well, patterns, tactics, you have a vague idea about what that is, but how does it all connect? Well, this little slide here actually shows the very simple iterative process that takes some kind of initial or non-existing or existing architecture, because this should fit into a maintenance evolution phase of a life cycle as well. Then you have some requirements down here, and they are of course the input. So now the architect, that's the blue guy here, this one. The blue guy here, he performs a design activity that produces some kind of artifact. And in our world, it's an architecture which is view-based, and it should then illustrate how this system deals with the concerns the stakeholders have. Okay, but it's merely a candidate. It's not something that we have decided is good enough yet. Instead, it moves on into this other activity that is also typically performed by the architect, but now it's an evaluation. And as I said before, there are different ways of evaluating. You can do evaluation by argumentation. You can have models where you can actually come up with performance estimates. You can talk to your stakeholders and try to convince them that this is it. There are many different ways to do this. You can have a formal model, and you can run verification tools on your formal models, and you can come up with guarantees for certain system level behavior. But after this evaluation, you have like a decision point. You can go either back up here and refine the architecture, or at the end of the day, it could also be that you're happy, you're satisfied, this architecture, and you convince your stakeholders this architecture meets the requirements that you have on this system. So it's kind of interesting that this little simple model does it all. But of course there are so many things involved in here, and I think that one of the biggest challenges here is that you're on a very abstract level and you talk about very complex concerns. You talk about security, you talk about performance, you talk about availability. And how do you do that when you don't have code? How do you do that when you don't have test cases? Well, you have to accept the fact, and I think that you do this intentionally or unintentionally whenever you code. When someone asks you to well, do something, your brain goes to work. And suddenly it starts to think about, something which is kind of sketchy, which is kind of rough, but it gives you a direction. And then you take this and you work on it. You polish off some rough edges, you add some things, you add more details, and you do this before you start to code. And it can also be that you, at some intermediate step, you start to talk about, well, classes, start to talk about how to relate the classes to each other. So, you're doing this, but it's kind of challenging the first time you do it. Remember the first time you programmed? Was that easy? That was kind of abstract, wasn't it? What is this? Variable? Assign some to this? Okay. It was kind of challenging. And this is also challenging. But don't give up, because I think that when you work together with people, when you need to agree on certain things before you branch out and do the detailed design and all the coding, well, you need this level. You need this language. You need to be able to design for requirements, do the evaluation, refine until you can reach an agreement at that level. So don't be afraid if you, well, if this is this too abstract? Is this too much? Is this too little? Don't be afraid. It's okay to make mistakes, and you learn from them. So the output down here, the architecture. What is the architecture? Well, you saw the views. The view tells us that the architecture may consist of anything that provides some kind of argument that can convince the stakeholder that we actually satisfy your concern, or we deal with your concern in this architecture and we do it like this. And it can be by, well, we can actually say that it can be use cases, it can be a class model, it can be one of these boxes and lines, it can be a PowerPoint with bullets and lists of bullets, it can be anything, as long as it's useful. When I started with software architecture, it was actually another century. So it's more than 20 years. And at that time, it was something called boxology. People actually refer to it as boxology. Some people call it a little bit later, but still, they call it design by PowerPoint. Because, you know, PowerPoint is good at boxes and arrows, but that's more or less it. So things have happened, but still, I don't think that this boxology is too bad, actually. I think that the fact that you can take a system at a very high level and decompose it into subsystems and assign responsibilities to the subsystems, that is a great value, because that is how you start to mentally process a complex system as a human being. We decompose. We try to divide and conquer. That's our approach. And for that, the responsibility structure is a neat tool. The responsibility structure, a set of responsibility components, and the connectors that tie them together. Okay, that can be one architecture view, the responsibility structure. And the core architectural ideas we can capture in here is decomposition and allocation of responsibilities. And we can use the responsibilities, and we can use to some extent also the patterns that we can infuse into these responsibility structures to argue that we actually provide something that is sufficient to address certain concerns our stakeholders have. So what do we use here? Well, we use UML component diagrams, the interfaces, and then we add responsibilities. And we may create responsibility structures for each and every view we have, or for each view where it's useful. So we can do it for a first level decomposition, as you guys have done. And we can use it to reason about security, availability, any, or I should say, most of the concerns that we can have with respect to a system. So, what you see here is the good old client-server architecture that you have seen so many times now that I didn't bother to add an animation. I just superimposed the UML component diagram on top of it. So why is this better than a picture with iPads and something that looks like a PC tower? Well, why is it better to have UML component diagrams? Well, it takes out some bias here. It's a little bit cleaner. You don't have to answer the question here is, okay, so you will only have an iPad client. Or, okay, so this should be, you should actually have a simple tower PC here as the server. You can remove that bias by just saying that, well, we're not talking about machines here. We're talking about software components. And these software components, they have responsibilities. So in this case, we can just think about, okay, here we have 1, 2, 3 core components, a client component, application server component in which, well, we have a web app running, and then we have some persistency component that has some Hibernate component running inside, and, well, no one really knows what's going on yet. But at least it's a first step towards setting the scene for the developers. Because if you show this picture to a group of developers, I think that most people will have an idea what this is all about. I hope. And there will also be ample opportunities for discussion. Because people start to argue, okay, why do you do it like this? Why have you split them up into 2? Why isn't there a third component? Well, that will be the result of something like this. So, how do you do this now in your architecting effort, the design activity in the iterative process I showed you before? Well, I just want to show you this little colorful picture here, but I would like you to look at this, and that. The quality attribute scenarios, those are the scenarios you derive together with the stakeholders, or they produce them for you if, well, if you have skilled stakeholders. Some are, believe it or not. And then what you do here is of course that you take a quality attribute scenario and you check the current architecture you have. And you say, what type of responsibilities are required if the system should elicit this behavior, exhibit this behavior as described in the scenario? What is needed? And also, on this side here, which subsystems should be responsible for this? So we didn't have a quality attribute scenario in the first assignment in that sense, but you actually did something like this, but for a functional requirement. There was some, well, according to some of you, extremely vague requirements. We can't possibly do anything with this. And I understand that, but they are kind of vague on purpose, because if I gave you too much detail, you will spend too much time on the architecture. And some of you will end up with very detailed designs, etc. And it's also not much more for me to write, of course. But still, what you did was that you took some description. What was it? Some business intelligence function somewhere with data, processed, well, not in real time, but offline. Kind of a scenario-ish. Not a scenario like a use case or so, but you could imagine a couple of them based on that 2 sentences or whatever it was. What did you do? You extracted responsibilities. What is needed in the system here in order to support this vague quality or functional statement or requirement? With the responsibilities, you started to look at, what do I have here? Well, I already have a box here which is called persistency, or, well, database. I know you prefer to use that. So this responsibility definitely goes into that box. I throw that responsibility in there. What else do I have? I don't really have something for business intelligence processing. I don't really have a dashboard here either. So I add those components. In order to map the responsibilities to something, I add something. But again, it's a decision, and now we're coming back to instance for example, maintainability here. What was the maintainability? Well, one of the things were localized change, avoid ripple effects and so on. And we all know that one of the design principles that was on one of the final slides for the Tuesday lecture was the single responsibility principle. That's why you don't mix something with some responsibility into your persistency component that should actually sit in a, well, user management or whatever. Because if you mix responsibilities that are not really where you have high coherence, well, the coupling here will be tight. And if you change something, you have to change every dependencies, and suddenly your persistency is tightly connected to your user management, and that is not a wise move. So what you do here is that you analyze your scenarios, and if it's use cases or if it's quality attribute scenarios, or of course if you have some other type of requirement specification, you analyze those. You identify, you allocate responsibilities by mapping them to architectural elements. Okay, so that was the, well, that was, let's say that this was the high-level functional first-level decomposition. I haven't really assigned any responsibilities to this one, but there are a couple of interfaces. Most likely there is some Hibernate interface there that the application server component or the web app actually uses to communicate with the persistency, whatever that is. There is some kind of RESTful API for the web app, and the client is most likely some kind of web client and web browser-like client. This was one view. Let's think a little bit more of another example then. Think about a security view. Okay. Security. That means that, well, we have the client, we have the application server here, and since the clients are interacting with the web app, that's like the weak part of our system. And we need to think about security, how to secure the interface with the web app, to the web app. How do you do that? Well, one alternative that we would like to exploit here is Kerberos authentication. Authentication where you have a shared key that is generated separately in another subsystem, but then it's shared with the application server web app here to authenticate requests that enters the system. So what we need to do then is of course to come up with Kerberos authentication for this system. And now, okay, Kerberos is a tactic. It's a proven way to secure the system here with authentication. So what do? Well, if you're lucky, someone has done the homework and produced tactics for Kerberos authentication, almost like a design pattern. And you look it up and you see, okay, how can I put this into the current context, this system? Well, first you have to understand what is needed, what are the responsibilities that you need to introduce to your system if you would like to have Kerberos authentication, and where should I allocate them? Well, you study. You go back home, you pick up the best book, the book you didn't read while at university, and I need this. So what we do here is that we add a connection to a component where you have a key distribution center component. And this doesn't have to be something that you develop. This can be something that already exists in your organization. But still, if you have something like, well, this box here, this one here, well, that behavior will affect what should go on in here. So the security view should explain to the developers, because they are interested in this, and any other stakeholder who has a stake in this, who is concerned with security, that by doing this, we will secure this part of the system. And we do that by introducing the KDC, the distribution center, and of course there are some dynamics here. And that is also part of the architecture description. It doesn't have to be as detailed as this, but it should at least contain sufficient enough information to guarantee that all components, subsystems that are involved here, and there are a couple now. There is one, there is two, possibly three, and of course these guys. They are involved and they communicate, they interact. And what do we need when components interact and they should behave in a certain way, in a certain order? What do we call that? Well, we need certain rules for interaction. We call that a protocol. So the protocol here describes how the interaction takes place, how the different components are involved and when. Okay? So now we had the functional first level decomposition. That was one view. And here's another view. And we can in fact say now that we can combine the two, if we would like, into a more complete description of the system and the responsibilities we have allocated to the subsystems. And we consider both functionality and security. The part here doesn't really include any true evaluation, but what we have to do is, of course, to go through this method, whatever that method is, design for more and more attribute scenarios in this case, or if it's use cases scenarios, until we have no more. And what we have then is views with responsibility structures that combined show how the system addresses the concerns our stakeholders have. So in fact, it's not just one pack of requirements. What you do here is that you take some initial or existing, you design for one attribute, one architecture concern. And this can be a set of scenarios. It can be for each property, a set of scenarios. You come up with a candidate, you go down here, you evaluate the candidate, you go back, didn't work out, so you refine it a bit, evaluate, okay, but still, we still have attributes in line, in queue here, waiting to be designed into the architecture. So you need to take, well, evaluation, is it Is it the fact that we have we satisfy the current set of attributes, or do we satisfy all attributes, all concerns? So even though you have an evaluation which says go, this works, it could be the case that we have additional ones that we haven't designed in yet. So this is an iterative, incremental approach. You remember where you heard that last time? Iterative and incremental. That's the way we work. So I would actually argue that to some extent, not completely, you can actually do a little bit of architecting as part of each of your sprint or whatever iterative incremental method you use. You can actually do some architecting. Not everything, because some things must be decided up front. Some things. Not all, some things. Okay, so I see that it's time for a little break here. So let's go for the usual 10 minutes, okay? See you then. So, okay, we move on after the break. For the break, we looked at, so to say, the home-brewn approach to architecting, well, with a very casual, laid-back, let's take the attributes, let's identify what type of responsibilities, how to organize or allocate responsibilities to various elements and so on, and then structure maybe using patterns, Well, that might work in a smaller project, but just to give you some kind of idea of what could be involved in an architecture, in architecting for a somewhat larger project, we will have a look at the ATAM, trade-off analysis methodology, architectural trade-off analysis. The objectives, this is like a workshop. So it's something that takes time, involves a lot of people, and that means that what you will see now is a very coarse grain. Again, it will not be just. I don't ask you guys that you should be able to do this, because that is like a week of training or something and a certification. So no, but it should give you some kind of insight in that there is not just the complexity of the system itself, there is also the complexity induced by the people involved in this. And ADAM is a way for how you can deal with these two complexities. So the objectives here are first and foremost to understand, remember this is a workshop, so together we should understand how an architecture satisfies certain quality attributes. Another one, and here comes the trade-off, start to understand how these quality attributes interact. And how to figure out what are the trade-off options and analyze them and find out which one to go for. The only thing we know here is that these decisions will be made with some degree of uncertainty. We don't have complete information. That causes uncertainty. And we know that things will change. That causes variability, which is another source of uncertainty. So lack of knowledge and the fact that things will change later down the line in this project, well, so that's why it's so important that besides making some decisions up front, we also study the risks, look at the options and alternatives. So we have some kind of risk management early up front in the project, so that we don't have to pause the project if it turns out that something changed or if new information changes the picture. Now we come to the people complexity. People involved. There is an external group of people, the evaluation team. These are the guys running these workshops. They are like coaching the other participants. Then we have the decision makers. And our decision makers, they can be engineers, they can be architects. But we also have other stakeholders. And you see the etc. at the end there. Customers, users, investors, etc. Suddenly, for a system of some complexity, this can be quite a huge group. So typically you involve proxies here. So you have product managers instead of customers and users, etc. Investors can be upper management or managing a product line, something like that. But this is still a group that is complex to manage. And now we need to over some period of time, make them understand the quality attributes and how the architecture satisfies them, the basis for the trade-offs, and how to manage the risks. And the 4 steps of ATAM here involves presentation, risk identification and analysis, an evaluation, and a reporting phase. And what's important here is that they have 2 perspectives. They have one, let's call it an external perspective, which involves the stakeholders besides the decision makers. And then we have another perspective which involves the decision makers, so architects and engineers, etc. And the process looks like this. And we will now go through each and every one of these steps. And just to show you the complexity here, we start with the presentation phase. And the presentation phase approaches the workshop participants from 2 ends. One is, of course, to present ATAM, what a method is all about, what expectations they may have, and also answer whatever questions that pop up. Then you move on into something that is more concerned with the actual project. And the project leader describes business drivers and an architecture. So this is an evaluation methodology. So we have something. We have an architecture. So start with the business goals that motivates the entire effort. Continue with the architecture. And this can be the project leader or one of the architects or a group of architects. And then connect it to the business drivers. Explain how the architecture addresses them or supports them or whatever word you choose to use there. So that's the presentation phase. So now each and every one should have a rather good understanding of what to expect from ATAM and what the architecture looks like. So now you can move on into the analysis part. And now you have to, as an architect, try to understand the architecture. So this is an analysis of the architecture that you currently evaluate. And there are some specifics here. One is the quality attribute utility tree. That is, if you have alternatives, say that you have, well, we had a Kerberos decision before, remember, for the security. We decided to go for Kerberos. Why did we do that? Well, one reason there could be that, well, we're working in an organization where we have many systems and we don't want 15 different username password combinations for each and every employee. That will just create weaknesses in our system. So instead we go for this centralized approach, and we require that every project uses that. So there could be like alternatives in our decision making, and we can generate, yeah, this alternative with respect to this or that quality, for instance, effort, time, etc. We can use some kind of, some very simple utility method. Utility means value. If we do this, we create this much utility. If we do that, it's that much utility. So we try to estimate the relative contribution of each alternative so that we can come up with some kind of ranking. So what does the ATEM team do then? Well, the ATEM team, they take the scenarios. And the scenarios, they are actually coming from the stakeholders, the other group. And they have ranked them according to their, well, relative importance. And the ATEM team takes these scenarios and they, from an architect's point of view, look at the architectural approach. So what is the approach here? Well, it's actually the strategy, the architectural strategy. So what is the architectural strategy with respect to security? Okay, now you as an architect, you must step up now and you have to explain to the evaluators, the ATEM team, and justify your decisions. And you do that primarily by walking them through. Take their hand and walk them through a scenario or a set of scenarios. An outcome of this walkthrough is that you will get a list of potential risks. It may reveal weaknesses in the design. But it may also give confidence that your architecture actually meets what's required. What they call non-risks here. So it highlights, put the light on potential risks, and you can start to move away from the non-risks, focusing on the risks. Now we have done something that comes from the evaluation team. The evaluation team is kind of composed of architecture experts. They should know what they do. But we can move on and we can, from a other stakeholder perspective, look at this. And what they do is that they analyze these approaches from their perspective. And they can continue to brainstorm and prioritize scenarios, because as they work with the architecture and the scenarios, they may generate more. But the idea here is more to test. evaluate, not identify risks and weaknesses, because they are not that knowledgeable necessarily. So the reporting then takes place down here. You have evaluated the architecture and you have come up with something that satisfies the stakeholders and the evaluation team. But it might as well be that you go in, sorry for that, that's an arrow, go in that direction. Because you have the risks. And that might require that you go back and refine your design and so on. Oops, like that. Okay. So this was the high-level description. And you see that business drivers give us quality attributes that give us scenarios. We have the current architecture, architectural approaches, the strategy, the mechanisms, whatever you choose to call them. Just, it's this, don't touch this. Sorry. Don't touch the whiteboard. It's smarter than you are. So you come up with the decisions and you can analyze them. And to drive the analysis, you use the scenarios. Okay. You see down to the, at this end here, we have a couple of boxes. And we will not delve into details here, but it's different types of results that come out from the analysis. But let's move towards the more detailed. Now you have the big picture of this methodology, and we can move on and have a more close-up look at the ATEM here. So, a detailed description. You present ATEM, and then you move on to elicitation analysis. For that, you will use 3 types of techniques: utility tree, some architecture-based elicitation and analysis techniques, and possibly scenario brainstorming and prioritization. So this is about, well, what do we need to analyze the architecture? Well, we need some kind of understanding what we mean by utility, the relative contribution of different options, design options. We need some understanding about the architectural approach, and we need some understanding about what are the scenarios, quality concerned scenarios. So the second step, present the business drivers. And this is kind of a lengthy process. This is not a 15-minute show here. It actually involves a discussion to make sure that we all agree that this is it. Have we defined the system boundaries correctly? For instance, are there any other systems missing that we interact with? or in fact depend upon, or that depends on our system. What are the business constraints here? Time to market. What does the market segment look like? What is the customer demand? Are there standards? Presenting the architecture. Here, it's not just presenting the architecture, it's actually go through the different views, architectural views. And, well, it could well be that you have you use different models to describe this. But, yep, I'm a little bit pushing a little bit too fast here. But what's important here is that you discuss this part here. Architectural approaches used to meet quality attributes. This is more on the tactics side. You can also talk about patterns / styles. This is also part of the game. Now we move on. So now we should have some ideas about the business goals. We should have some ideas about what the architecture looks like currently, what kind of approaches we use, what kind of patterns we use, and so on. So we have some information. But now, what's the most important for the evaluation is to have some understanding about the quality we're after, the quality levels. And ATEM uses something called utility trees. And it uses this as a basis for trade-off analysis. And I think it's better if we just move on to an explanation. So before what does the utility tree do then? What it does, it characterizes attribute-specific requirements. What do you mean by that? Well, think about security. Well, one attribute of security was information security. Information security was concerned with, for instance, confidentiality, integrity, availability, etc. So you can actually, you see the tree, okay, you see the tree. But for each and every one here, for instance, availability, there might be alternatives. And it might be more important or less important than some other attribute or some other requirement. So we may say that availability is much more important than confidentiality. Or we may say that confidentiality is much more important than performance. We need the information in the utility tree in order to prioritize. Is this more important than that? Because that is needed when we talk about trade-offs. Because if something is much more important than something else, what should you prioritize? Well, of course, the important one. So, this little 3-stage or steps or values that you can assign to a requirement can be used to prioritize. How important is it for the success of the system? And how difficult is it to realize? Very, very simple model. Value for customer, in principle, cost for customer. And you can use that to prioritize requirements. So, how do you get from business drivers to these requirements? Well, here's an example. If you have an e-commerce system, there are two drivers. Security is important. If you have a very competitive marketplace, customers are moving quickly, you have to be, well, aligned with the market actually and move with them, because if they move and you're not there, they are somewhere else. Another example in a streaming media system, quality of service is of course key. Here in this example we have latencies and number of simultaneous streams. If there are like pauses in the movies or in the music or in the whatever it is you watch or listen to, well, that's not a good idea. You will not have a returning customers. So latency here is super important. It's probably much more important than the response time. You can probably accept 15 seconds, 10 seconds time to load. Maybe you have a preload of your movie stream or whatever in order to come up with better guarantees for meeting the latency requirements. So you trade response time for better latencies. So how do you do this then? Well, who has the answers to the questions here? Value and cost. Who has the answers? The evaluation team? No. The architects? Yeah. Them and the stakeholders. And what they do is they take these scenarios and they rank them according to these two criteria: importance for the success of the system and the difficulty. Using high, medium, low importance and high, medium, low difficulty. So the result may look like this. And what is this? Well, it's a utility tree. And what you can start to see here is actually that our stakeholders, they have ranked a couple of scenarios. Minimize storage latency on customer databases to 200 milliseconds. That's medium for the success, and it's kind of easy to achieve. It's not difficult to achieve. What else do we have? We have a power outage at site 1 requires traffic redirect to site 3 in less than 3 seconds. That is something that has, in principle, very low value for the success of the product, but it's difficult. It's high on the difficulty level. When it comes to these prioritizations, well, this is what you base your decisions on when you have a decision like, should we support this or should we support that? There is one here, one which is kind of interesting. I just want to show you this one. Data confidentiality. Credit card transactions are secure. So that means, if I'm not, is it 1 of 10,000 transactions that is insecure? Should be something like that. It depends, of course, on the system and the type of business drivers you have. Okay. So ATEM uses scenarios, as we said, for driving well, the evaluation. Use cases, they're using growth scenarios and some exploratory. And what is this? Well, this is actually something that can be used to, you try to predict, because maintainability, for instance, that is, well, you try to look into the future. You bring out your glass ball and try to figure out how maintainable is the system. When it comes to performance, you think about throughput. Well, you can use different types of scenarios to well, what if? What if this happens? Or you can use more anticipated changes, like what will happen if the system, well, the number of users is increased by well, 100, or they double or triple or whatever. What happens? So now we have many scenarios. We have ranked some of them with the utility trees. We have the growth, we have the what ifs, the use cases, etc. So now we can start to look at the analysis, and from the perspective of the architects or decision makers, and also from the perspective of the stakeholders. Now we can start to identify sensitivity points and we can start to identify trade-offs. So what is a sensitivity point? Well, a sensitivity point is like a must-have. If we don't have this, it doesn't matter in principle. So it doesn't matter how fast the system is if it's not secure. It doesn't matter how secure the system is if it's not performant. So what you can do here is that you can identify sensitivity points that, well, correspond to component properties, subsystem properties, or responsibilities that are critical if you would like to achieve some or satisfy some specific attribute. For instance, changing the timing scheme here would be easy. However, we can project the ripple effect here. So just replacing this subsystem for another one, that's easy. However, there are so many dependencies. So that's a sensitivity point. Trade-offs then. Sacrifice something to get something. So now we have two outputs from our analysis, two types of output. We also have the risks and no risks. Examples of risks here, or I should say one example. Rules for writing business logic modules in the second tier of your three-tier style are not clearly articulated. This could result in replication of functionality, thereby compromising modifiability of the third tier. That's a risk. A non-risk, assuming message arrival rates of once per second, a processing time of less than 30 milliseconds, and the existence of one higher priority process, a 1 second soft deadline, that seems reasonable. That's actually like, okay, you thought about this. It sounds reasonable. We believe you. So the output here are focus on the prioritized scenarios, of course, the architectural strategies to achieve these scenarios, and the response from the architect is used to build the confidence here in the architecture. And more about the scenarios here, now from the stakeholder perspective. So you move on, and this might take, I think, 3 days, 2 days, 4 days. It takes time. Depends, of course, on the size of the system. But at the end of the day, you will have risk themes that impact your software architecture and your business drivers. And you need to take that into account into your, well, possibly refining the architecture until next time you do the evaluation. So, as I said, this is a complex approach, but involving lots of people and having a complex system is complex. So it's not that easy to get away from the complexity. So today's takeaway, approach this incrementally, iteratively, with evaluation. Make use of this trade-off. Prioritize the quality requirements. This is more important than that. That is less important than something else. That will help you a lot when you make the decisions. And as I said, don't be afraid to take small steps. It's much easier to end up in a tar pit if you try to make too many decisions in one iteration. And I think that this, well, is possible to combine with many, what people refer to as modern development processes, with iterations and increments. You'll just have to be a little bit more careful with the type of decisions you have to make up front and the type of decisions you can postpone. So that's it for now. And there will be a new assignment tomorrow, together with corrected assignment ones. They will start popping up this evening. So I see you next week. Till then, take care.